Polynomial division. Polynomial division can be used to determine factors, find the real zeros, and solve equations. So we can divide polynomials using a process that's similar to long division of numbers. So let's review what we used to do a long time ago when we had two numbers like 902 divided by 7. So we took the divisor of 7 and then we placed the dividend of 902 underneath the symbol for division. And then we found the quotient and the remainder. So we'll go back over all those terms again after we go through the process, just to jog your memory. So we took 7 and we saw if it went into the first digit, and 7 does go into 9 one time. Then we took 1 times 7 and subtracted that from 9, so we got a 2. Then we needed to bring down the 0 placeholder for the tens place to make this number of 20. And then we said, well, how many times does 7 go into 20? Well, it goes at most 2 times. Then we took 2 times 7 and got 14 and subtracted that from 20. So then we had to borrow from the tens place and say, well, 10 minus 4 is 6, 1 minus 1 is 0. And then 7 doesn't go into 6, so we had to bring down the ones place of 2, and then we had 62. Well, then we said, well, how many times does 7 go into 62? Well, it only goes in 8 times. 8 times 7 is 56. So our last subtraction gives us 62 minus 56 will give us 6. So finally we found the remainder, and we knew we were done because we were out of digits to bring down. Then 128 is what we called the quotient. And remember, 902 was the dividend, and 7 was called the divisor. And then we had to check our math. We had to say, well, we need to find out if 128 times 7 plus the remainder of 6, does that equal 902? Well, yes, it does, because 128 times 7, let's see, it's 56, carry the 5, 14, 9, carry, I don't need to carry, yes I do, carry the 1, and I get 896 plus 6. Yes, that does equal 902. So that's a reminder of how we did long division with numbers. In the next video, I'll show you how that transfers to long division of polynomials.